do this, since it's just the opposite of differentiation, there's a couple of things we need to remember. Okay, first of all, you know, if I do some differentiation and I say differentiate this polynomial, and you go, okay, well, I can differentiate. I get 6x plus 5, and I'm finished there. Okay, but if I were to go this way, if I were to do anti-differentiation, which is going from the gradient function to the original function, how do I get that 17? So when I go backwards, when I go from the gradient function to the original function, I will not be able to get this guy. Okay, I won't be able to get that value. So what that means is that when I go in this direction, and I don't have a point on that curve or something, I'm always going to put a plus c there, because I won't know what that number is. So this term right here, when I don't know what that number is, we'll call that c, and that's the constant of integration. Constant just means a number. Okay. All right, so if I want to find the original function, remember that's the gradient function. My rule in algebra is this, and in words it's this. I add 1 to the new power, and I divide by that new power. So f of x is going to be add 1 to the new power is 6, and divide by that new power, which is 6. And remember, since I can't differentiate back to find that constant number, I'm going to do a plus c. I guess you can also, you know, that over 6, you can write that as a coefficient of 1/6 if you feel like it. All right. So if I'm just given one term like that, it's pretty straightforward. Add 1 to the exponent and divide by that new exponent. Okay, we'll try another one. F dash x is 6x squared. So what's the original function? And I may have to do some simplifying here. Add 1 to the exponent, which makes that 3, and divide by that new exponent. And I'm always going, if I don't have a point on the curve, I always do plus c, which stands for the constant. And 6 over 3 can differentiate, or not differentiate, I mean simplify, because it's 2. 6 divided by 3 is 2.
Do you have to show that it?
No, you can write it just straight to the 2 if you want to. You don't have to show that part. Okay, easy so far. Just doing anti-differentiation with a constant number, that's just 7. Well, 7 isn't just 7. There's actually kind of, you can say that there's an x there to the power of 0. So that's kind of how you have to treat it. So when I add 1 to the power and divide by that new power is actually 1. So this equals 7x to the 1 over 1 plus my constant, which just equals 7x. So the shortcut is obviously not to show all this work, but if you're given a constant, if it's just 7, then when you anti-differentiate it, it's going to be 7x. Or if it's 8, it's 8x, and if it's minus 2, it's minus 2x. And don't forget the plus c. Okay, just like differentiating, I'm going to do this to each term. I'm going to add 1 to the exponent and divide by that new power each time. So when I get the original function, it's going to be add 1 to the exponent is 3, divide by that 3, add 1 to the new exponent here, which would be 2, because there's actually a 1, invisible 1 there. So that's minus 3x2 over 2. And remember what that 5 differentiates to. It differentiates to, anti-differentiates to 5x. And don't forget that constant there. Now here, again, if you want to rewrite that as 1/3, you can. It's the same thing. All right, what do we do if the coefficient's a fraction here? Remember that, okay, well, we still add 1 to the exponent and divide by that new exponent. But when we divide by that new exponent, another way of saying that is just put it in the denominator, because that denominator means divided by. So I would add 1 to the exponent to get x to the 3. And then I'm going to divide by 3, and that means that guy is already down there. And dividing by a 3 means I put another 3 in that denominator and connect them by multiplying. So I'm going to get 2 plus a constant. So my final answer is going to be 2/9. 2/9 x cubed plus c. Okay, and I wrote that as a coefficient. If you want to put the x cubed next to the 2, you still can. So again, if it's a fraction and you're dividing by that new power, just stick it in the denominator with the times sign, and that's the same thing. Okay, the last examples are just, you're going to have to do some algebra first before you do the calculus. And remember, we want individual terms to anti-differentiate, not brackets or things that can be simplified. So first, we simplify this by just expanding. And I get 8x cubed minus 16x. Okay, now I do the calculus. Add 1 to the exponent, 8x4, divide by that new exponent, minus 16x2, divide by that new exponent, plus my constant. And these are going to simplify because 8 divided by 4 gives me 2, and 16 divided by 2 gives me 8. 2x4 minus 8x squared plus my constant. Okay, last example here. This goes back to some algebra of simplifying. So I don't want to do any calculus as a fraction like this. So I will look to see if I can do any cross-canceling, and I can't cross-cancel these x's because they're not factors. So I look up here, and I say, wait, an x is a common factor, so I can factor out an x from the top part and get x plus 5. And on the bottom is still that x. Now, still haven't done any calculus yet, but before we do, those guys can cross-cancel. So really, what I'm doing the calculus on is simply x plus 5, and not this messy-looking fraction. Okay, so just take a look at that. I factorize the top and then cross-cancel those x over x to get that. So now, when I do the calculus, add 1 to the exponent, which would make that 2. Divide by that new power, and that plus 5 anti-differentiates to 5x plus my constant. Okay, so that's that, and I think we're going to do some practice out of our books right now.